Assalamu alaikum students. Today we will begin the lecture number 2, and in lecture number 2 we will start today access networks and physical media. Access network, that how the services we are using in our homes over the access network, we have to look into it, and what physical medias are there which will connect our access networks to the internet service provider network. How to connect end systems, our end systems, end hosts, user hosts to the edge router. Okay, and what physical media we will be using in order to get this connection. For example, if we have our residential access network, in residential access networks we have our smart router in our home that will have our Wi-Fi network connection, and as well as it will have our Ethernet connection with the service provider network. Institutional access network, for example, if we have a network in our school, university or company, definitely it has to be connected with the service provider network. And similarly, we use our mobile devices on the mobile network, and our mobile network should also have a mobile access network facility. Okay, so all these networks which we are using in our daily lives, they should have a connectivity with the service provider network. Either we are using a network in our home, in our office, in our school, in our university, or the mobile access network. Whatsoever network we are using in our daily lives, they should have a connectivity with the service provider network. So we are on our access network, and we are using our end systems, end hosts, and whatever device we are having in our access network, it should be connected with the service provider network. Keep in mind, bandwidth is a major concern here. It is measured in bits per second at the access network, that how much bandwidth you are getting on your access network. So it depends that what type of bandwidth you are having in your access network, either it is dedicated or shared. As we discussed in our last lecture, that the shared bandwidth means you are getting a share of it. You are not getting the whole or dedicated line or the bandwidth. You are getting that bandwidth is being shared among number of users, because the cost of that bandwidth is less. You are paying low cost for that bandwidth. That is why you are getting a share of it. But if this is usually given to the home users, home subscribers, okay, because they don't pay more and they don't need to be connected all the times over the network. So whenever they want, they can use it. So they need a share of it. But whereas if we talk about the companies or the institutions network or the universities or the schools, they have to be connected for approximately 8 to 10 hours. They need to be connected, or more than that, they have to be connected to the network, and they need the network services, and a huge number of users are using that network, institutional network or the company network, so they need more bandwidth. So they need actually a dedicated bandwidth. Definitely for the dedicated bandwidth they have to pay more, okay, so that they can get the whole pipe. Okay, whole pipe means the whole bandwidth coming in that link should be utilized by them. Okay, so shared or dedicated, it should be clear to you now. In the old days, before the digital subscriber lines, or you could say that before the cable modems or the DSL modems, we were using the analog lines, which were with the help of a modem, dial-up modem. We use dial-up modem in order to connect our PC to the service provider network. So here we have our home PC. Okay, it will be connected to the telephone company network, and in order to connect our home PC to the telephone company network, we do need a dial-up modem at our home. Okay, so we connect our computer to the dial-up modem, okay, with the cable, and further the telephone line is terminated into our dial-up modem. Okay, and dial-up modem is basically connected to the central office from where we are getting the telephone link. Okay, so further this is the telephone network of the telephone company, and definitely the telephone company will have the ISP modem. Okay, example, if they want to get the services of the internet, definitely they need the internet service provider modem in order to connect to the internet. So it uses basically existing telephone infrastructure. In the old days, home is connected to the central office of the telephone company, and the bandwidth or the data rate was limited up to 56 kilobits per second, and it was a direct access to router. Often sometimes it is less than 56 kbps, kilobits per second. Why it is 56 kilobits per second? That because you know that 64 kilohertz is the frequency of the telephone lines. On that frequency we can get maximum up to 56 kilobits per second bandwidth, data rate. This is not the bandwidth, this is, you could say, it is a data rate which we can get on that dial-up telephone line. Can't serve and phone at the same time, not always on. You can use one facility at one time, either telephone or the internet service, not both at the same time. But now in the DSL connection you can use both the services at the same time, and if you have subscribed for the InVision, you can use all the three services. Okay, internet, phone and television. Sort of, you could say that the sort of cable modem services. For the cable TV you are also using at the same time, three services, triple play. But in the old days it was simple telephone line. We don't want to waste more time on it. So digital subscriber line, DSL connections, which we are using nowadays. Okay, PC in the home is connected to DSL modem, digital subscriber line modem, and the home telephone is connected to the splitter. Splitter will give two lines to you, one for the internet, okay, to the DSL modem, and the other will be given to the telephone. Okay, existing phone line is from 0 to 4 kilohertz phone, 4 to 50 kilohertz upstream data, 50 to 1 megahertz, 50 kilohertz to 1 megahertz is the downstream. Okay, so this telephone line, which is coming from the DSLAM, digital subscriber line access multiplexer, this is called DSLAM. It is located in the central office of the telephone company. DSLAM is located in the telephone company office, central office we call it usually, central office. From there you get a line, okay, that will be terminated at the splitter. Splitter will split into a telephone line and a internet line. Okay, so this DSLAM is further connected into the telephone network. Okay, so in telephone network similarly it will be used for the voice communication, and the router, the other part of the DSLAM will be terminated into the router, and router will be connected to the internet in order to provide you the internet service. So also uses existing telephone infrastructure. We are using at the back end the same telephone infrastructure which we were having before. Up to 1 Mbps upstream link. Today typically less than 256 kbps we are getting because it is shared, and up to 8 Mbps downstream. Today typically we are getting less than 1 Mbps due to the shared dedicated physical line to telephone central office, but the telephone line is the dedicated one, but the internet connection is being shared for the home subscriber. Okay. In the residential access scenario, you have also the provision of cable modems. Does not use the telephone infrastructure, they have different infrastructure. Instead they uses the cable TV infrastructure in order to provide you these services. HFC is called hybrid fiber coax. Why it is called hybrid fiber coax? Because it is a combination of optical fiber and coaxial cable, the black one which we use for our dishes. Okay, so this network, hybrid HFC network, is a combination of optical fiber as well as the coaxial cable network. That is why it is called hybrid fiber coaxial network, HFC network. Asymmetric, up to 30 Mbps downstream, 30 Mbps you can get the downlink, and 2 Mbps upstream. Asymmetric means, why it is called asymmetric? Because the loadable bandwidth and the upload bandwidth downstream and the upstreams are not the same, they are different. That is why it is called asymmetric. Okay. Network of cable and fiber attaches homes to the ISP router. Now your home is attached to the service provider with the help of two type of cables, optical fiber and coaxial cable. That is why it is called hybrid. Homes share access to the router, unlike DSL which has a dedicated access, but here they share, okay, access to the router. Look here, residential access cable modems. Here they have the optical fiber transport at the back end. The internet is coming from the IP backbone network, okay, and the public switch telephone network. Both services you are getting from the regional cable head end, okay, office, and they have the optical fiber rings, okay, IP over SONET, ATM or whatever WAN technology, WDM is used at 622 megabits per second rate, okay. This is distribution hub, okay. It is further connected to the optical fiber nodes, 27 Mbps downstream and 2 Mbps upstream per node, and one node is serving multiple homes, okay, because as we said that it is shared. Here we talk home shares access to the router. So it's mean this optical node is sharing and it is having further, this infrastructure is on the optical fiber cable, but where you are giving access to the, from where you are giving, from which node you are giving access to the home subscriber, this is on the coaxial cable now. So you are terminating for the local loop till the homes, okay, from the last optical fiber node you will use here the coaxial cable. This is the tap in order to connect this home to this node, this home and this business office to this network. So here, that is why it is called HFC, hybrid fiber and coaxial, because it uses a combination of both cables, okay. The backbone is coming on the optical fiber, and where you terminate your backbone, and further if when you want to give a shared access to the home user, there you will use the coaxial cable, okay. Cable network architecture overview. This is the overview. This is the head end, cable head end, this regional head end, okay, this head end, okay. From here actually cable distribution network is simplified, typically 500 to 5,000 homes, and these are being shared from the cable head end, okay. Now these are your servers from where you are getting the services. Now different servers are kept over their network in order to give different type of services to the home users. All these home users are sharing this cable distribution network, and they need different type of services, so they will get from these servers. In one home, particular home, where the coaxial cable will be coming, terminating into the splitter will have a TV box, okay, in order to give you the cable TV service, and further it will run the coaxial cable further, and it will have a cable modem on which you can connect your PC in order to get the internet service. Same like the DSL, here it will have a coaxial splitter, okay, which will give you the cable TV service as well as the cable internet service inside the home environment, okay. Here we will use FDM, frequency division multiplexing, in order to give you different channels on the single cable, because on one cable you will be getting different channels, okay. Multiple channels you are getting for the video. You have different channels on your TV, you can search them and you can watch them. So multiple channels are there for your video and for your data and for the control. So different channels are there, so it will be using frequency division multiplexing in order to give you on different frequency different channels and data for the internet. And definitely this network does need control signals in order to control the data and the video, so it will be sent on a different frequency. So all the things, all the channels and data and the control signals are being transmitted over different frequencies, When the fiber is coming to your home, now we don't have the coaxial cable. The fiber is directly terminating into your home without the coaxial cable. It is not HFC now. Okay, so from the internet, the central office, the telephone company, it is connected to the internet, and their router is connected to the internet further to the OLT, optical line terminal, okay, or terminator. That will give you a cable, optical fiber cable, to your optical splitter, and from there it will be splitted for different ONT, optical network terminator, and optical links from the central office to the home. Okay, two competing optical network technologies are there: passive optical network and active optical network. These are on the optical network. When we say that we have a services of optical network and the fiber is being terminated into our home, and we are getting the internet service or the TV service or the telephone service over the optical fiber network, we could say that it could be the infrastructure, the network of the company who has laid out its optical network. They could follow two type of technologies: passive optical network or active optical network. Passive optical network or active optical network, they have their own advantages and disadvantages. Okay, for example, active optical network, the switches or the routers which they use, they have the electrical powered switches or routers. Okay, they could be used for to cover the more longer distances. Their maintenance or troubleshooting will be easy. Okay, whereas but definitely it will be a costly solution. Whereas passive optical network, their switches will not be electrically powered on. They will split by using the optical splitter, and definitely they will cover the shorter distances. Okay, and they will serve a limited number of users in one optical fiber strand. Okay, and their maintenance or the troubleshooting will be little bit more difficult as compared to the active optical network. So both the technologies, they have their own advantages and disadvantages. It depends that the company which is laying out its optical fiber network, they prefer to use what type of network, of either passive or active. But definitely, if you have the services or the access to the optical fiber network, as you know that now, first STC, they have laid out their network, and so many of us are using the STC optical network. They are giving 1 MB, 2 MB, 4 MB, okay, 20 MB, 40 MB, 100 Mbps, but definitely it is shared. If you test the speed with the speedtest.com, you can look into it that you are not getting the whole bandwidth for which you are subscribed, or you are getting definitely a share of it, because the home subscriber, definitely they will be sharing. But much higher internet rates are there. Okay, fiber also carries television and phone services along with the internet data services. Okay, if you want, you can have it, the television service. If you don't want, you can simply have the telephone and the internet service. Okay, so we call it, usually if we avail all the three services, we call it triple play. Triple play means data, voice and video. Television, voice telephone, and video, the television. Okay, Ethernet internet access. Usually inside our home or inside our buildings, we prefer to have the Ethernet network. Before we were having it on 10 Mbps, 100 Mbps, and now we can have it on 1000 Mbps, which is definitely equivalent to 1 gigabit per second, gig internet we usually call it. Before it was having the speed of 10 Mbps, then 100 Mbps, and then 1000 Mbps, megabits per second. This was called the simple Ethernet. Ethernet. This is called fast Ethernet. And this is called gigabit Ethernet. Why? Because 1000 Mbps is equivalent to 1 Gbps. 1 gigabit, 1000 Mbps is equivalent to 1 gigabit per second. That is why it is called gigabit Ethernet. Before that, we were using 100 Mbps. That was called the fast Ethernet, and before that, we were using 10 Mbps Ethernet, simple Ethernet. Fast Ethernet, gigabit Ethernet. So, if we are deploying Ethernet network anywhere, we should keep in mind that now the Ethernet cards coming in the system, most of the system, they are gigabit Ethernet cards. So for gigabit Ethernet cards, we should have the infrastructure, cabling infrastructure, which could support the gigabit Ethernet. So we should use the gigabit Ethernet cables, category 6E enhanced or category 7 cable for the Ethernet. We should not use category 5 cable, because category 5 or simple category 6 cable will not support more than 100 Mbps. If we want to go more than that, we should use the cable which can support more than 100 Mbps up to 1 gigabit per second. That is called gigabit Ethernet. But if you check with the speed test or the speed testing tools, even though sometimes we are not utilizing the whole capacity of our network, okay, on the systems, because it also depends that how much you are getting from the internet. It depends on that. If you have gigabit Ethernet inside, but you are not getting gigabit capacity from the internet, it means you are not utilizing the full capacity of your network. So even though 100 Mbps will be sufficient, but in order to keep the future enhancement in our mind, we should go for the one which can cope the future requirements as well. Sorry, this is the Ethernet switch which we have in our local area network, local area LAN. Okay, and we can connect our end systems, the desktop computers, by using 100 Mbps network card inside the computer and the cable which can support 100 Mbps to the Ethernet switch. And switch also should be 100 Mbps fast Ethernet switch, and definitely the server will be connected to the gigabit Ethernet port in the switch, because some ports are gigabit Ethernet port in the switch to give the gigabit speed to the machines which do need a higher capacity for the servers. Ethernet switch will be connected. This area is called our local area network as a whole till here, because this port of the router is also included in our LAN. So till here we call it local area network. Okay, so this is our local area network for our company or whatsoever network we have in our school or company or Jamia university. This is our institutional or the company router. This side, this interface of the router is the local LAN interface of our router, on which our local area network is terminated. And this side of our router, or this interface of our router, is called the WAN interface, the serial interface, because it is connecting our institutional network to the internet, to institutions ISP, from where the institution is getting the internet service from its internet service provider. So this interface is called the serial interface or the WAN interface, on which we are getting the internet service from our service provider, and this interface is called the LAN interface or the Ethernet interface, on which our local area network is terminated. Clear? It means the router will have both the interfaces, the WAN interface to connect our institutional network with the wide area network, and a LAN interface to connect our local area network to the router. Clear? So a router will have the LAN interfaces as well as the WAN interfaces. Could be more than one LAN interface and more than one WAN interfaces, serial interfaces. Clear? Typically used in companies or universities or institutions, etc. This type of setup. It could have 10 Mbps, 100 Mbps, 1 Gbps or 10 Gbps Ethernet. I have written here the speeds on the board. Today end systems typically connect into Ethernet switch. We connect our end systems, either these are the simple hosts or the servers, into the Ethernet switch in order to sum up there, and from here they will be collectively, their data will be going to the router. And router is a device which will route the data of these end systems to the internet, because this side is the internet and this side is our local area network. In our homes we can have also the wireless network, or even in our institutional networks. For example, if you can see here, you can connect your laptops, iPads, PDAs or mobile phones with the internet with the help of wireless network. That wireless network inside your building is called a Wi-Fi network. Okay, wireless fidelity. Wi-Fi mean wireless fidelity. Wi-Fi mean wireless fidelity. Wireless access network, shared wireless access network. It is shared. This is your base station or access point. This access point should be connected to your router. Same like that, our switch in the Ethernet network, in the wired LAN, in the last diagram, our switch was connected to our router. Okay, and it is giving us the wired service, not the wireless service, to the end hosts. But if we say that our end hosts, they need the wireless service, it's mean here we need a device which is called an access point or a base station, which can serve these end hosts or the mobile hosts wirelessly. It must also should be connected to the gateway router, but through the wired link. This is the wired link. So this access point you are looking over here, it is connected to our that switch with the wired link. But further it is giving you wireless service, Wi-Fi service, irrespective of what wireless device you are using. Clear? So this is a shared wireless access network, because we are sharing this, connects end system to our router. So our end systems are connected to the router with the help of a base station or an access point, Wi-Fi access point, wireless access point. Shared wireless access, why? Because it is shared among the users who are using or getting the service from this access point. And you are getting this service via base station, and this base station is also known as Wi-Fi access point. Okay. Usually in the Wi-Fi network we call it access point, and in the mobile network we call it cellular base station or base station. Okay. The standard for the wireless LAN is 802.11 B or G. You could say A, B, G, and the latest which is currently being used is N. So Wi-Fi, its data rate starts from 11 Mbps and goes up to 54 Mbps. But the new technologies and Wi-Fi 802.11n is providing you 64 Mbps as well. These are the enhancements keep on going on. First they invented 802.11a, then B, then G, then the latest one is N, and they call it due to next generation network. Okay. Wider area wireless access, it is provided by telco operators and approximately equal to 1 Mbps over cellular system, EVDO, or high speed digital download packet access, or HSUPA or DPA. Next up, what it is coming, WiMAX. WiMAX up to 10 Mbps. No doubt the data rate is less than the Wi-Fi in this case, but the benefit is it can provide you or serve you over a wide area. The range can be extended even outside of the building. Wi-Fi access you are getting inside the building, okay, but if you want to get it outside the building, you can get up to a limited distance or a range outside. Then it cannot serve you up to certain distance. The Wi-Fi access point can serve you, but if you want it for a longer distance, the technology is called WiMAX. Okay, its standard is 802.16. Okay, for the WiMAX the standard is 802.11, and for WiMAX the standard is IEEE standard is 802.16. Okay. Home networks. The components of a typical home network are, if we talk about digital subscriber line or a cable modem, okay, you do need a router or a firewall or a netting device, network address translation device. You do need an Ethernet switch in order to connect your wired devices into it. You do need a wireless access point in order to connect with the help of Wi-Fi or PDAs, iPads or laptops or notebooks to the internet. So the cable modem, basically it contains to and from the cable head end. When the cable is terminated into your cable modem, further the cable modem will be connected into the router, which will also have the firewall facility in it, and the router will have also the Ethernet switch in it, okay, to connect your wired computer and also the wireless access point to it. So this is your wireless access point, which will be helpful in order to connect your wireless laptops to this one. Now these are different devices. This is your cable modem, this is your router, your firewall, your net box is also inside it, your Ethernet switch is also inside it, your access point is there. So it's mean all these are in one box now are coming in the smart router in your homes. So you are not having in your home these separate boxes. You have only one device in your home which contains all these services inside it. It is a cable modem, it is a router. Inside it you can also configure a firewall. Inside it you have a net box, because you need the network address translation facility inside it. You do need the service of an Ethernet switch in order to connect your wired devices into it, and you do need the service of an access point in order to connect your devices on a Wi-Fi link, on a wireless link to your cable modem. So all these are summed up into one single box, which is your smart router, okay, or DSL modem, which you are getting from the STC or Mobile company and you have installed in your home. Okay, it is a single box. Okay, clear? So you can connect your wireless laptop with it, your wired computer with it. Okay. physical media which we are using in order to make our networks. What that media is carrying basically? That media is carrying the bits. And a bit is the representation of the data which propagates between the transmitting computer and the receiving computer. So transmitter and receiver, they are connected with the help of a physical media. That media could be, if it is a wired connection, so definitely on that wire the bits will propagate. Definitely these bits are carrying our data, and this is called a physical link between the sender and the transmitter and the receiver. And what lies between the transmitter and the receiver? The physical link is there between the transmitter and the receiver, on which the transmitter can transmit the data and the receiver can receive the data. Clear? If it is a wired media, you call it a guided media because it has a direction in which the data is being guided. The transportation of the data is being guided. Wherever there is a wire and in which direction the wire is going, definitely in that direction the data will propagate or be transmitted. Signals propagate in solid media. It could be copper, it could be optical fiber cable, it could be coaxial cable. Okay, and the signal will be propagated in that direction in which direction the media is going. If it is wired. But what if it is wireless? If it is wireless, you call it unguided media. Why? Because in wireless, the electromagnetic waves will be radiated in the air. In the wired media, if this is the wire between the transmitter computer and the receiver computer, so definitely the data can go either in this or in this direction. So it will be guided. Wherever the wire is going, the data can go in that direction. But if we look here, this is in case of guided media. But what if in case of unguided media, if this is a computer and it is having an antenna, wireless antenna, when it radiates the signal, it will be radiated in the air. If this is the antenna, wireless antenna, the signal will be radiated like this in all the direction equally. So this is called omnidirectional antenna, which radiates the energy in all the direction equally. If you do need to radiate the energy in a particular direction, you need directional antenna. So directional antenna will radiate energy in a particular direction. Okay? It conserves the energy and it radiates it in one particular direction. So we can have directional or omnidirectional antenna. Omnidirectional antenna property is this: it radiates energy in all the direction equally, and directional antenna radiate energy in one particular direction. So usually we have in our wireless devices for the Wi-Fi access omnidirectional antenna which radiates the energy in all the direction equally. Yes, please. Thank you. So unguided media, signal propagates freely. Example, radio signal propagates in all the direction freely. For the guided media, you have twisted pair cable. Okay. Two insulated copper wires are there in one pair, and it will contain the 4 pairs. Okay. You could have category 3, traditional phone wire, whose data rate is 10 Mbps, Ethernet cable used in the phone network. Category 5 cable, 100 Mbps Ethernet cable, which is used in the computer networks. Okay, this is the cable, category 5 patch code. This is the connector. Okay, we will look further into the details of the cabling when we will attend a cabling lecture in our lab, physical cabling. Okay, so till here we stop today, lecture number 2, and further we will continue in our lecture number 3. Thank you.